Okay, guys, last video for 1.8, absolute value inequalities. We have two cases for these inequalities. We have the in case is what I call it. And that's, just for example, say the absolute value of x is less than 3. That means these are all the possibilities. You want everything that's within a distance of 3 from 0. In interval notation, that's -3 to 3. Now, very similarly for b, if it's less than or equal to, it's the same thing, it's just with closed circles, okay? Or, especially if you're on MyMathLab, you'll see these as brackets. And you'll see open circles as parentheses on MyMathLab. So do be aware of that. And this is just everything within 2 from 0, including those endpoints. So there it is in interval notation. Then we have the out situation, when it's a greater than sign. If x is greater than 1, then we want everything that's a greater than a distance from 1 from 0. So we would use open circles or parentheses here, and we would go -infinity to -1, union 1 to infinity. And then likewise with b, everything greater than or equal to 2 for the distance, start at -2 and 2, work your way out. Okay, so that's the way we're going to handle these types of inequalities when we solve them. So let's go to this. Examples. Solve each inequality. So it's going to work just like it did before, is I'm going to go ahead and I'm going to isolate the absolute value sign, which I have in this case. And I'm looking at this and I'm saying, okay, well, this is less than, so this is an in situation. Now what I'm going to do is I'm going to give you a number line. It's not for x. This is the number line for 3x minus 4. Since it's in between -2 and 2. Here's 0, okay? And what this is saying is that within this range right here, from -2 to 2, all of this stuff, that's as far as 3x minus 4 can be from 0. Hopefully you can see that. Now, we don't want 3x minus 4. We want x, of course. But you can probably see from this line graph that it's easy to see, well, that means that -2 is less than 3x minus 4 is less than 2. So we have one of these compound inequalities we saw in 1.7. So now I'll just solve this like normal. +4, +4, +4. This is going to be 2 is less than 3x is less than 6. Okay, then I know I have to get the x by itself, so I'll divide everything by 3. Don't have to flip any signs. 2/3 is less than x is less than 2. Now I can do my actual graph for x. Okay, and I know it's going to start at 2/3 and go to 2. And I'll use open circles. So right here. And in interval notation, my answer is going to look like this, 2/3 to 2, not including. So that's what that'll end up looking like. Okay. Let's look at B here. B says 5 times the absolute value of x plus 1 is greater than 10. So similarly, right here, I have to isolate the absolute value. So I have to divide both sides by 5 before I do anything. Don't have to flip a sign, but we are watching for that. Right, if we do. So the absolute value of x plus 1 is greater than 2. So in this case, since it's greater than, this is out. So once again, I will make a line graph for this absolute value x plus 1. So here's -2, here's 2, here's 0. But if it's outwards and not equal to, we're talking about this stuff right here. Okay, so what I'm saying here is that x plus 1 is all the stuff over here and all the stuff over here. Okay. That being said, we can see that I can't write this as a compound inequality. However, I can write it like this. I can say that x plus 1 is less than -2. That's one situation, sorry, or x plus 1 is greater than 2. And from here, these are pretty easy to solve. Or x is greater than 1. So I have these two situations. I'll draw a graph for these. And I see I need a -3, I need a 1, and x is less than -3, or x is greater than 1. And now I can write my answer in interval notation. And my answer in interval notation is -infinity to -3, union 1 to infinity. Okay. So I encourage you, do work the problems in the book. They get a little bit tougher than this, and if you can't get it, make sure you ask me. I'll post a video on it. Okay. The last thing I want to talk about are a few special circumstances with these. I've kind of put it into some special cases. Suppose I have something like this. Absolute value of 12 minus 9x is greater than or equal to some negative number. Well, an absolute value is always positive, and a negative is always negative. So anything for x makes this true. So my answer is just -infinity to infinity, or all real numbers. The next case, what if I have a similar situation and it's always positive, but it's less than something that's always negative? Well, then nothing works. There's no solution. This will never be true. Something that's always positive cannot be less than something that's always negative. Okay? And what about here? 7 plus 2x in parentheses, or in absolute value is equal to 0. Well, you don't have to split into two terms, because then it's just 7 plus 2x has to equal 0. That's the only thing 7 plus 2x can be equal to. So in that case, you might only get one solution. Okay, so that wraps up 1.8, guys. Make sure you go through all the book problems, look at all these videos, make sure you understand everything before you do the quiz. And remember, the quiz is due Sunday at 11:59. So that would be 6 days from now.